Welcome back to Made Up of Wires. We're going to be decompiling some Castlevania Symphony of the Night. We're going to get back to Karasuman. Karasuman, interesting because while the character is a boss, it's not structured necessarily like any of the major bosses, but it has a lot of code like a boss does, just loaded into the clock tower stage instead of being its own stage. If you're not familiar with the Castlevania Symphony of the Night decompilation project, you can go to soten.z.dev to learn more and find a link to all the code that's been decompiled so far, as well as all the awesome tooling that's been created for this, and a link to Discord as well. I've been busy, a lot of life happening, so I haven't been on Discord for a while, but there are a lot of people there. It's the holidays, so who knows? Merry Christmas coming up for all of those who celebrate. Let's get back to it. So when we left last week, we were about 91% matched. So this is a matching decompilation project, which means we're going to try to create C code that will compile back to exactly the same machine code that was on the disk. And so on the left here, we have our C code that we're trying to write. In the middle, we have our target, which is the machine code that you can find on your copy of Castlevania Symphony of the Night on the PlayStation version. And on the right is what our C code is currently compiling to, and we have some errors that we still need to get matched, and that's what we'll be spending our time doing today. Hey, Dig Down Deep, good to have you. Always nice to see you in chat. All right, so I'm trying to remember what we were doing and where we left off. I think we have some elements here that, some globals that should be pretty straightforward to get rid of. I don't remember. Yeah, we do have some debug code here, and that is already taken care of. So we don't have to worry about that. So I think I can get rid of most of these. Or if I can't, then let's go through and fix those references. So we have global symbols that we can give addresses to. This one's a little interesting. So usually we have 244 to 256, right? Or 240 to 256. So that would be 116 later. No, sorry. 16 later. Let's try that. Let's try 176 here and see if that gives us what we want. We'll go down to 174. There might be a couple other references here that share that. So yeah, not quite far enough. Let's try 182. Not far enough yet. 186. Still not far enough. 192. There we go. So we'll need to fix a few of those along the way, but now we know it's 192. Should probably put that one in there. Brute force equals best force. Yes, I agree. I don't mind trying a few things out before doing the math. Let's try to get the rest of these more than that. Let's just do a find a place on this. Oh, this one is actually not quite the same. This one's much further out. 4680. I am going to grab a calculator for that one. That looks like it might be 64. Or so out. Entities are BC in size. It's this. Looks like 96 out. And that would get us to 256 then. So this is to the end. Up to 256 entities can be active in the game at any point. Let's try to find that, make sure I got that number right. And we are getting closer as we're going through this. That's mostly because these aren't symbols, but they are array offsets. And so GCC will do all kinds of different things to deal with that. I am going to do this, I suppose. We can just do a find and replace for all the 160s. Let me do this one first. Plus 4, 680. And that's going to be 256. Let's see if there's any more of these. Oh. So now we can get rid of the 160 as well. And that replace this up here. Oh, we might have a 224 in some places. And that got us almost 4% more just by doing that. And so that rearranges some of the code and consolidates some of the references. All right. So let's go back up, and we need to clean up variables. See how many of these temp v0s exist. Usually those will go away. So here we have a negative fixed value. This is going to be negative 0.75. And I think what's happening here is we have these comparison operators, and then the assignment down here, I think that this is being duplicated and then just pulled out and shared. And the top is going to be positive 0.75. Let's move that in here, and we'll slowly start working that out. Let's go to 131 on the side here. And the code might actually generate to be approximately the same, but it's not code like any human would write it usually. And yeah, so this is basically saying it's a clamp. If this is less than negative fix 0.75, then we're going to set it to negative fix 0.75. And I think we have a macro for this. So it might be worth grabbing that macro. And I think it's just going to be checking that velocity directly. And so we're going to do a minus equals. And since we know that this is a fixed value, that's subtracting 1/64th, which is 0.015625, which I like 1/64th better. Other people, especially the Europeans, they love their decimal. But over in Freedom Land, we use we use fractions for things like this. Especially for powers of 2. And yeah, so this simplified quite a bit, and all of it's matching now. So I'm pretty happy with how that turned out. We're going to do the same thing down below. And we'll get to the PSP version eventually, but that's should confirm whether or not this is actually what we want. And this one is going to be positive fix 0.75. I probably should put the negative inside the macro. It doesn't make a huge difference, but I think that looks a little nicer. And this is going to be the same thing. Adding 1/64th. It would be nice to know what step this is. We will have to come through and add an entity extension for Karsuman. We do have these inverted. It's probably something that I screwed up when dealing with some go-to rearrangement. All right, so down here we have a load of the value 1 that's occurring in ours, but not there, not the original. This could happen for all kinds of different reasons, and we have a control statement switch here. And so it may be related to something like set substep, which I need to check if that has a argument or not. That is being moved out and shared with some other code that's calling set substep. We have an extra no-op here. Then we have a funny value here down on 167. It's FFE4. So I think what this unsigned 16.2 is actually a signed 16 timer. And so I'll rearrange that in the mode that timers usually are written. That may be where the extra 1 is coming. And I think we can do a not and then pull this step plus plus up. So this is just a timer. Hey Roman, good to have you back. All right, and so let's try to figure out what's going on. We have this negative 1C here. It looks like we're doing a minus equals. And what I need to figure out is we're allocating the entity here. This doesn't necessarily make sense. Because when you allocate an entity, oh, I guess the create entity from entity would take care of this. Allocating an entity basically resets all the fields within that entity itself, and so doing a minus equals of 1C I suppose that would have to do with the initialization that comes from create entity from entity. And so maybe that does make sense. And the compiler likes that quite a bit, so I guess I'm happy with that. So we're just missing one no-op here. Let's try changing this to a not instead of the explicit 0. Animate entity, does that really have a return value? Let's look. So there definitely are cases where the return value is being checked, both with not and with an explicit 0 check. And we have another one down here. So I'm not sure why we're getting the additional load of a 1 let's look at V0. It looks like it's coming from the switch. And the switch could be just an if, else if conditional control structure as opposed to the switch. The switch is nicer, and usually switches are used for steps. So I'm not quite sure what's going on there, but I think I'll leave it, and then we can come back with the PSP version and see what's going on there. 215, and it could be that there's other code that is similar, but hasn't been fixed yet, and so there's some optimization that isn't kicking in because the similarity of the different cases is not there. You lose some of that when you untangle the go-tos and other labels. Yeah, because this looking similar where there's an extra knop in there. And so it could be that all of these need the same pattern of either saying not animate entity or animate entity is explicitly equal to 0. I'm not sure. We'll figure it out eventually, though. We have another case of this timer here, and so we're going to do the same thing. It's going to be a not minus minus, and that'll go right into the condition of this if statement. There's a few things down here that are worth cleaning up. They might not matter on the PlayStation, but they are going to matter on the PSP. Things like this pass-through assignment here. I'm a little surprised at this XY, and I'm guessing it's... No, I was going to say it's just order, but Byler didn't like it when I put it in the correct order. Or the expected order. So I could be wrong there. There might be other ordering things, and again, the PSP will help us find that. All right, let's try to untangle this. So temp A0 is velocity Y. So this becomes a minus equals. Oh, Roaming says he was helping with Twilight Princess and they're at 100% functions matching. Awesome. That's amazing. So they probably have a bunch of symbols that they're going to still be working on. Let's find this 257. So this is also compiling to a match. I'm going to try a few things here and see if we get the same result. What I want to do, so I'm going to move this in place, and then I'm going to copy this. So this looks like a deceleration function. And that doesn't look like it was doing much good. I'm going to put that back because we are matching, and we'll pick it up on the PlayStation or the PSP side. All right, so we have a scale. Again, this is probably a pass-through assignment. Get rid of these extra variables. Greater than equals becomes a greater than. Oh, interesting. So they, Romy says, they ship symbols with the game, which is awesome. And so, figuring out the function ordering. So once again, we have this load basically in the same looking spot. Our timer again. It looks like offset 8 is going to be a parent entity pointer. Same thing with the switch, another constant that that is showing up likely due to something in the switch, and we'll figure that out later. Usually facing left is used as a Boolean. Same thing with the knob here. The timer maybe... I'm going to move the timer down. No, I was hoping that the timer would be... we know it's assigned and not unsigned, and likely signed. 1 second. Line 336 is a weird argument, says roaming. Now I move that around. Move entity. Yeah, I don't think entity move entity takes anything as an arg, so that's a good call. And let's see if there's any more of those, because that was showing up quite a bit. Yeah. 2 ends up in the A0 register, which causes that issue. I think we got all those. Thank you, thank you. And a very similar construct then to above with velocity x and velocity y. Let's work that out. This becomes a minus equals. This one will become a minus equals. timer again. I felt like it's been a long time since I looked at Twilight Princess, but I think my impression of it at the time was that Nintendo wanted to make something Okami-like, and so they made that's the one where Link turns into a wolf, right? And I thought that was a little strange. Oh. No, what? Oh, I'm hitting command instead of option, like I'm expecting to hit. I'm typing on a laptop keyboard for a while. And my muscle memory is all off. Animate entity. Oh yeah, it does take 2 args, okay. A very samey code here, which is why we saw the optimizer had so many go-tos. Usually there's not a separate bar like this. And we keep skirting around that 96. I think we've actually gone down a little bit for a match. I'm not too worried about that. Hey, JM Sun. JMS Sun. Good to have you. JM's Son. Is there anything to call out here? It looks like we have another timer. Decrement. A couple pointer warnings that I should go back and resolve. Getting a little further away, so let's go down to 253 and see what why that might not have been happy. So usually what happens, I'll have to go back and look at this. All of the the U16 subscript 2s should actually be S16, so getting the signed value instead of the unsigned value. And that might help out quite a bit. And yeah. So, roaming. Do you think that Twilight Princess got to the end because it had more people working on it, faster people working on it, or something else? What I'm trying to figure out is what has made Soten take so long compared to some of these other games. I would assume that a 3D N64 game would be more complicated, but maybe like rendering code is consolidated, whereas here basically everything renders itself. And so you have 200 different ways to render things. All right, so this is gonna be the last pass here, and then I'm gonna try to clean up some of the variables. And then we'll go grab the PSP version. Let's see if there's any plus equal ones. Usually these don't make a difference one way or the other. It does occasionally, but usually not. What is MM? Roaming says, dedicated people. They had symbols and a debug build. Yeah, that would be helpful. I wonder if there's anything. I haven't looked at the CES demo. Is it CES demo for Soten? I wonder if there's anything there. I know like Dragon Blitz played through that and found that a significant amount of the game was there, just blocked by what seemed to be ability gates, and it turned out that he could navigate the where you're supposed to have the bat sonar ability. He could navigate that without the sonar ability, and so he could escape the sandbox that they had done for the CES build. So I think we still have these odd integer loads from time to time out of order down here. The only thing that I think I'm mostly concerned about, like those will work themselves out. 256 is weird. Or sorry, 456? Yeah, this entity range here being out of order, that's strange. What I think, though, is it looks like something here is out of order. And then 516, this is towards the end. So there might be an additional variable here. I'm going to go through and try to get rid of as many of these variables as possible. If we can. Oh, another timer. Keep coming across the timers. Those compile to the correct thing, but they are not correct. And they could be causing some of the other issues. Okay, we got them all. Oh, Majora's Mask. I see. Yeah, I'm pretty sure that this scroll X variable probably doesn't exist. It looks like that's the only one remaining, though. And that's the 14. So we can get rid of a bunch of these. I'm not the biggest Zelda person in the world. There are several of the games that I liked quite a bit. This is that same thing. So I think I'm going to consolidate all these to just var v0. I guess we could make them velocity x and velocity y. That probably makes the most sense. Let's call it delta y. And most of these then just fall away. We know we have that one, and I think we have temp A2 as well. All right, so those two. The temp V1 I'm less sure of. The other I think should go away. 43 we have some a missing breakpoint, which is a little strange. We can go back through, so we have through case 14. It's possible that there is a case 13 that that is missing. 3C looks like it actually would be 15. Let's add a case 15. No, maybe it's 17, sorry. That give us the RO data that we want? No, it doesn't. All right, we'll go try to figure that out with the PSP. So we're at 97% and gained about 6% so far. I've really liked the Game Boy Zelda game, and then is that Link's Awakening? And then I thought the remake was, yeah, Link's Awakening. I thought the remake was incredible. It's probably one of my favorite Switch games. So we do have a little bit too much on the stack still. We don't have too much. So maybe these delta X and delta Y come down here. We only have X. Let's try reusing it here. It doesn't help the... Yeah, I really think that this should go away. I'm a little hesitant to do it right now. And that's just because I want a way to be able to reference that when we get to the PSP. So let me get rid of some of these comments and then we'll go find that. Thanks to Project Oblivion for mapping all these symbols between the two versions of the game. Super helpful. And we're looking at entity Karasuman. Let's find that in PSP EU SCNZ1. We're going to be non-matchings. So we only have 2 jump tables in the PSP version. Jump tables, the way that they're generated, are a bit different between GCC and MetroWorks. So it's not unexpected when it happens. So we're going to take what we have over here and just duplicate it. And we're going to have a bunch of symbols and other things like that that are incorrect. We do have, oh, I should have fixed the pointer conversions, but that's okay. 260, we're going to cast this for now. It is going to be an entity pointer eventually, but for right now, we're just going to cast it as an unsigned 32. And that won't result in any data loss. It's just not very nice from a source perspective. Understanding what's going on. Why are we storing a pointer as an integer? And it looks like here our types may be wrong. So we have a frame property. Yeah, okay. And we're treating it as an unsigned 8. I guess we're treating it as a signed 8. Okay, that's fine. Doesn't make a huge difference either way. And we're only at 80%. So a lot of things that the PlayStation glosses over, we're able to deal with. What I want to do maybe is come down here to 491 and focus on that section. And we can use the decomp to kind of help us through this. This is somewhat interesting. It's incrementing a second variable and then basically using these as pairs. It does do the +1 down here, but it does look like there may be a second. I don't know. It could be how M2C is dealing with this. Down here we do have tile scroll map, or tile map scroll X. It is reused everywhere, so we don't have a separate variable there. That's what I thought, but you don't know. And then it looks like there is a slightly different structure down here. This may be extra code on the PlayStation version. A bunch of types. The PSP is more sensitive to that as well. So let's fix those. I'm going to start on 492 and we'll go down. So this looks correct. The velocity X being less than 0 does not. But here it does look correct. So M2C came up with the same thing on both sides. This looks like it might be related to how the stack pointer is, how the variable getting pushed to the stack maybe on ours. We're loading offset 20 from the stack pointer, and that is happening, but just out of order. We do have some sign extensions here as well. So delta x probably is a sine 16. And that changes things a little bit, but possibly a little closer. That prime means delta y is also sine 16. That didn't change much. I guess let's go top to bottom and see. I was hoping that bottom section would be a little more straightforward to work out. I'll replace some of these x values with constants or decimal values. Does that use the same variable as the switch statements? They are using the same value, and that may or may not be the correct interpretation. Right now, the stack is correct, which makes me think that I have it correct. But we'll see. We'll see if that's the case. This is a little strange. Let's go up here to 32. This is compiling to the right thing, but checking the current step, is the bottom bit set on that step? If it is, set the step to 14. That's bizarre. So like if you're an odd step, I guess if you're odd step and the hit flags are set, let's look at what that might be. I thought we had hit flags. So one is took hit, but we're masking the bottom 2 bits. We should have an enum for that, I think. Okay, I'm not going to worry too much about it at the moment. And then we come through. There's a move here from V1 to V0. I think there may be some conditions that are off. So it can be like a less than equals or greater than equals, something like that, that will throw all these around. So greater than equals is going to be the same as greater than 48. Let's see if that affected anything. Go from 80.88 to 81.28, so that, yeah, that's pretty big for something relatively small. And actually, this is probably the same down here, greater than DC. And let's see if that fixes it. That's another 0.1% anymore. I think that's it. A lot of register noise here, which is a little unfortunate. So the switches, if they're not implemented as a jump table, and this one looks like it's not implemented as a jump table, then you're going to see all the logic here. If it's equal to this, then go to this address. If it's, or offset, if it's equal to that, then go to the next one. And that's going to go all the way through, and they're backwards. And so we can see here, though, pretty clearly, we have our branch if equal to FF, and we know that's the last one. And then 16, 14, 12, 10, 8, 7, 6. And so we have all of those in ours as well, because that tells us that that outer branch probably has all of the cases that we need. So I guess we'll get down here on line 41. Our initialization looks fine, and then these look like they're out of order. And I think we'll see just a bunch of that kind of stuff that the PlayStation doesn't really have to deal with, or it doesn't make a difference on the PlayStation. It has its own heuristics for what order it wants to put those rates in, and will do whatever it wants. Let's look at animate entity. Make sure it has 2 bars. There's a couple things that may be going on. So this may be a knot. I don't think that changed anything. Still have the unnecessary move. Yeah, it doesn't look like it's changing anything to me. $68. Yeah, we're pulling in this S2 register, but again, it's for the Switch. In this case, still not using a jump table. $81. Looks like this is going to be signed. And, oh, no, not signed. It's going to be a, just being used as a Boolean. $90. Yeah, there's a lot of subtlety like this that PlayStation won't give us. So we'll have to get all these checks to be the right type. This looks like it might be backwards. Yep. We do have a sign extension here, though. Let's try the knot again. Yeah, there we go. Yeah, it may be. I was thinking the same thing, Roaming. It may be due to missing function declarations. It might not be. I'm going to go with not for the time being. And if nothing else is working out, we can go through and add the function declarations. My guess is that it's something unrelated, though. I think it's more likely that it's either incorrect types or incorrect conditions or something out of order, something along those lines. And there's things like this where when we're doing entity IDs, we have to make sure that they're global variables for the PSP versus constants for the PlayStation. So I'm gonna grab that constant. And let's see what it is. Oh, none of these have numbers anymore. Drat. I can't be bothered to count. All right, so 35 plus hex 50 is going to be, what, 40, no, 64, 80? That's line 115. So this is Karasuman Feather Attack. So we're going to use the EID function. So that means forget how these are declared. Oh, these aren't declared yet. So I need the where is pendulum weight defined? How is this working on the PSP if I don't have symbols for it? Oh, I'm looking at US symbols, that's why. That makes more sense. There we go. So it's D underscore PSP. And these are sign 32s? Yeah. All right. A lot of boilerplate. To get this to be the right thing. Semicolon. There we go. And that shows up there. Let's find all the other ones. I'm sure there's going to be several of these. And we could just get them all done at the same time. So we have the Orb Attack, Raven Attack Feather, and Raven Absorb. I don't know why, if we're generating the enum for all the entity IDs, why we just don't generate the EIDs for these at the same time, but I guess I'm just happy that they're generated at all. Very strange, I think, how these got allocated differently between the two versions of the game. Why is formatting screwed up? It seems fine. Line 30, I screwed something up. Thank you, roaming. So what's nice about having these entity ID names as well is it gives us some idea of what each of these parts of the state machine are. So we come through, and when Karasuman's at 6, he's going to go through, wind up, and then do his feather attack, along with the... We'll probably see that this sound effect ends up being the appropriate sound effect for that action. And a lot of that was just to get this, where was it? Where was the original create entity? Was it here on line 150? I think so. Just to get this in the right place. But by doing that, we got all of them in, and shouldn't have to deal with that again. All right, 180. We have a bunch of mess. So I'm guessing that this is an explicit check against 1 instead of the masking, or it does not equal 1. Or it is equal to 1. And these get swapped. Or equal to 0, I guess. I think I tried this, but I'm going to try it one more time just because I never learn. Yeah, no difference there. So the default function signature for C, if you're not familiar with the C programming languages, if you don't have a function signature available, is that all the arguments are integer size and the function returns an integer. And so when you're doing an equality check, then there doesn't have to be any casting or masking, sign extensions, things like that. Here we end up with some RO data that's different, which is probably fine. As long as these maintain the same offset. So this is offset 24 versus 0. So as long as there's a delta of 24 between all of them, that's fine, and that maintains that. I don't think it is there. Maybe it is. Yeah, 24 plus 8, 32, yeah. So I think all of those are fine. So let's go down to 237, and there's some sign, or some, yeah, sign extension issues. So here it looks like maybe these are different variables. This looks like it is just a sine 32 as opposed to a sine 16. So let's fix that. I thought there were other things where it worked better as a sine 16. This definitely works better though, this way. Let's look at the decomp. Maybe this is all different. And where can we look? Yep. So it looks like GCC optimized the shift out of here. So let's go back and look at that. That's looking much better. So I think this might be a comparison with the delta Y. That's not quite right. And we have this 8 here that's... Oh, shift by 3 is divide by 8. And that's what all this is. So this is just a divide by minus equals divide by 8. A lot of extra instructions for something that's pretty simple. And that's the kind of stuff that I think will end up being the cause for a lot of this other stuff. So everywhere we see that delta Y, we're probably doing that same thing. Yeah, where it's a minus equals divide by 8. And so that variable is going to go away then. And same thing here. And we might have been able to figure that out on the PlayStation. Definitely easier to do here. This one looks like a 5x16. One second. Nothing important. And so I think a lot of this is going to end up falling into place. Whether or not this bottom section is something similar remains to be seen. We might actually have too few variables now. Yeah, we do. So we probably need a second. So I'm going to add an offset, probably rename this offset X. And we'll have to figure out where the other one is being used. Oh, but that's a pretty nice problem to have. So it looks like these are out of order. $335, we have a incorrect type or an incorrect comparison. And it's possible that this is either matching or close to matching now on the PlayStation side. I guess that bottom section still probably is a little off. A very broken switch here. So we have a jump table in the original that's not getting generated. It's possible that there's some additional cases here that aren't being taken care of. Let's see if I still have that open. I don't, but we can get back to it pretty easily. So how many cases do we have? This is, we're looking at the E8 jump table. So we have 0, 1, 2, 3, 4, 5. So we should be going through 5. 6 altogether. Let's see where this is ending up. So it looks like this is right at the end. So I think there's an additional case here, and that case, so we have case 4. I think there's a case 5 that just breaks, and hopefully that's will give us what we need. And let's go back up and look at that switch. Yeah, so now that switch is using the jump table again, and some of the other stuff up above, everything was offset by 24 bytes. This jump table is 6 addresses of 4 bytes each. 6 times 4 is 24, so that makes sense that that is what is probably necessary. Out of order. And that, something like that possibly could be fixing a bunch of these. Still not fixed though, but we'll get there. I'm going to wrap this up after a few more of these. If there's anything that's not moves, I think does this have us at the end? Not quite. But we have ordering issues down here. Let's get those fixed. A lot of register issues throughout. Explode Puff, we have to deal with that. Let's do that. It's like ordering issue on 430. $42. All right, now we're down at the end. It looks like there's probably a second variable here, so we can pull that out. We'll pull it out as an index. Just another sign 32. Should we use I? We'll call it something else for now because we need a second variable. It's almost like one of these is being pulled out as a variable. And then used later on. So there's a little bit more going on. Offset X, I did change that to a sign 16, but it looks like it is a sign 32 down here. And yeah, then we still have some mess to work through down here. Possibly velocity X getting pulled out as a variable. So we'll have to go through and see how that is. What I want to do before ending for today, so we're up to 91% on the PSP. That's pretty good. We know we're going to have a bunch of stuff related to symbols that are wrong on the PSP as always, but those will get worked out. And looks like I screwed up something here. Fix that. What were we at before 97.32? Oh, we got a whole 0.7 improvement. All that work on the PSP for not 0.7, 0.07. So we'll come back tomorrow and keep working on this. We've been decompiling Castlevania Symphony of the Night, Karasuman. This is the main Karasuman state machine. We'll be back tomorrow doing the same thing. Adios. Huge gains, that's right. Get to the gym. Adios.